Good afternoon, everyone. The expert for today's session, Shri Y.P. Kajale, he has joined, so we can start the proceedings for today. So, on behalf of BMTPC, let me welcome you to this webinar series. Today is the third session of this series, and as I have been telling you that every third Wednesday of the month, we are organizing this webinar on a important topic which relates to all of us who are involved into construction of buildings and infrastructure. And today we are indeed quite fortunate to have with us Shri Kajale ji, who is a dear friend of mine, and we have been associated with him and his company for last 4 decades when I was in CBRI. So I will introduce him to all of you. But before that, let me tell you that this is the effort under technology submission of Pradhan Mantri Awas Yojana, which is being operationalized by Ministry of Housing and Urban Affairs. Through technology submission of Pradhan Mantri Awas Yojana, we are trying to inculcate good construction practices along with innovative and alternate building materials, construction systems and processes across the country. We do organize handholding programs, seminars, symposiums, roadshows across the country in partnership with the state governments, and try to spread awareness, try to educate the engineering and architecture fraternity, including policymakers, about the good construction practices. And as you might be aware that in 2019, at the behest of Honorable Prime Minister, Government of India organized Global Housing Technology Challenge, which was inaugurated by Honorable Prime Minister. And through that Global Housing Technology Challenge, we shortlisted 54 new construction system. And the system which is going to be discussed today by Shri Kajale was one of the shortlisted technology through GSTC India. And they also did a lighthouse project in Chennai using the technology which he's going to explain to you in detail today. And let me also share with you, there was a competition. There were 6 lighthouse projects using 6 broad categories of the technologies which were shortlisted through Global Housing Technology Challenge. And there was a the competition challenge within challenge that whosoever finished the project first, they will be suitably rewarded for finishing the projects early. So despite of COVID, despite of serious supply chain disruptions, despite of having difficulties at the site in Chennai because of backwater and all, they could complete, BG Shirke could complete the project within a year. So that was also the landmark or achievement by the company, showing the efficacy of precast concrete construction. As you all might be aware that Government of India through Ministry of Housing and Urban Affairs is disseminating information and promoting these new age construction technologies, which are not only resource efficient, climate responsive, energy efficient, eco-friendly, but also reduce the construction time considerably. So as I think Mr. Kajale will explain to you, the project of 1,000+ houses in Chennai, despite of COVID restrictions, could be completed within a year, within 12 months. And right now the beneficiaries are residing there. You can get all the details about the project along with the detailed compendium on BMTPC's as well as GSTC website. Last time when we met, I told you that there is a website ghtc-india.gov.in where you can get details of all new technologies and about lighthouse projects and about government initiatives with regard to new technologies. BMTPC, as all of you might be knowing, that we are established in 1990, and since then we have been disseminating knowledge about alternate, innovative and industrialized building system. throughout the country. And we are also, showcasing these new construction systems and alternate technologies through demonstration housing through PMAY. So demonstration housing projects are basically 40 plus houses which are constructed in different parts of the country, and showcasing one set of technologies. So let me also tell you here that with regard to precast is one of the most effective technology which can be used not only for mass housing but also for other kind of structures. And whenever we talk about precast concrete construction, every time several questions are being asked about its seismic resistance. So let me share with you that considerable amount of research and experimentation have been done, particularly by Messrs. BG Shirke. They have conducted several full-scale tests, and I'm sure today Mr. Kajale will be showing you the video as well as the experimental results, which establishes the efficacy of precast concrete construction. And please take it from me that there are several kinds of joints available for precast concrete construction. So if you are going for cumulative jointing or the kind of joint being developed by Messrs. Shirke, which is their patented item, they behave as if it is a monolithic structure. So absolutely there is no problem with the precast concrete construction if you properly detail the joints and get it experimentally verified. I think I can say without hesitation that Shirke is the only company in the country who have put considerable amount of money and time to collaborated with research organization. In fact, I was earlier in Central Building Research Institute, where Messrs. Vijay Shirke approached us, and it was 30 years back, and since then they have been evolving these technologies and developing these technologies. One of the recent initiative in which I was also involved along with Professor CBR Murthy, who is heading the CD39. CD39 is Earthquake Engineering Sectional Committee of Bureau of Indian Standard, and all the codes are being revised. So as chairman of CD39 and as that time he was director IIT Jodhpur, we have created a full-scale testing facility at MNIT Jaipur, and where Messrs. BG Shirke, they erected a 3-story structure using their technology, and it was tested, full-scale test, and that kind of test, that was first of its kind test done not only in India, but at very few places globally you will find that kind of testing. So with these tests, a lot of confidence is gained about precast concrete construction. So with these few words, let me again warmly welcome you. And because friends, this is a rare opportunity, and as I can tell you without hesitation that Yogesh Kajale ji, he is a blend of academic practice and he comes from industry. He has been doing projects for last 30-40 years, so he knows in and out of structural engineering, how joints behave, how the construction takes place, what are the design consideration. So it's a rare opportunity. Make full use of it. In case you have any doubt, small or big, please write on the in the chat box, and if time permits, I will ask Mr. Kajale to answer those queries of yours. So please write those questions in the chat box, and we will try to answer those questions. Some of you have asked whether these presentations will be made available to you, and as I told you that the entire session is being recorded, and the recording will be made available to you, and that will also be available on our YouTube channel as well. And also, if the expert agrees and gives us the PDF file of their presentation, we will email it to all of you. So with these words, let me have a pleasure to welcome Kajale, and let me introduce Mr. Yogesh Kajale. His full name is Yogesh Prabhakar Kajale. He is 1989 civil engineering graduate from College of Engineering, Pune. His core competency is the project conceptualization, engineering, planning and designing of prefab high-rise structures, engineering optimization and preparation of technical specification. He's a professional friend of mine, and I always tell him that I have come across very few structural engineers as knowledgeable as Mr. Yogesh Kajale. He is at present holding a very senior position in Messrs. BG Shirke construction company. Since 1990, he has been working in this company, and right now he is part of management and holding a position of senior vice president engineering. If I have to talk about his major achievements, he has a vast experience of 35 years in the field of structural engineering, and he also holds MCGM's structural engineering license in unlimited category. He has been instrumental in developing effective jointing technique and methods for prefab members, development of analytical software solutions for prefab joint design and detailing, and formulation of design standards and construction methods for prefab structure. He is actively involved in various capacities with Bureau of Indian Standards and helping them in formulating standards and specifications. He's also a member of a monitoring committee of CSIR for development of fast, durable, and energy efficient mass housing scheme. He was also he has also designed and developed indoor cricket academy, facilitating temperature and humidity simulation. I think in Mumbai, development of designs of high-rise prefab buildings, micro planning and monitoring of fast-track mass housing projects, design of large-span structures, including indoor sports, airports, etc. And as questions are being raised about efficacy with respect to seismic resistance, about the jointing. I told you in the beginning, and also Mr. Kajale was involved in experimental analysis and validation of effectiveness of prefab structures on assembly in full scale testing. And dear friends, full scale testing is needed if you want to simulate any new technology for seismic resistance. He's also involved into research and development, and has published several papers in international and national magazines. With these few words, I warmly welcome Mr. Y.P. Kajale and request him to deliver his lecture on the topic. Over to you, Kajale.
Hello, am I audible?
Yes, yes, you are audible.
Yeah. Thank
At
you.
least show your face to all.
Something has happened. I'm not able to connect to the video.
Okay, no issues. No issues. Okay.
Yes. Thanks for your kind introduction, Shailesh ji.
Thank you.
I'm simple a structural engineer working in PG Shirke for last more than 32 years. And when I started my career, it was as a design engineer, and I'm still doing the same thing. Of course, during this tenure of long 35 years, lot many things have been developed, and so many experimentation has also been completed just to validate what are our presumptions while we make the designs of the buildings. I'll just I'll start my presentation.
Yeah, you have to share your screen.
Yes.
Yeah.
So I'll cover this session in two parts.
Sure.
First, I'll emphasize what is the necessity of testing, particularly when any new system of building construction is being implemented on a mass scale, because safety is always of a paramount importance, and the design assumptions or presumptions can only be validated if the assumptions are weighted through a real size test. With this background, actually, see,
Slide show में चले जाओ. Slide, yeah. Go ahead.
With this background, uh, we started precast construction in India in 1971-72. It's a long story back. During those years, the full-scale testing facilities were not available in India. So naturally, low-rise buildings were constructed and the sub-assemblage testing was done. When the full-scale testing facility was created in India, we were the first to get our 3S system, rather the precast construction system, tested at CBRI Roorkee. A two-level structure was erected. This was in the year 2010-2011, and it was subjected to reverse cyclic loading by loading the actuator at two levels, at the upper level as well as at the lower level. So it was a ground plus one structure. Of course, this is not a ground plus one structure, but it was a representative structure of a real size building. Then thereafter, three-level structure were also tested, and almost 8 tests were conducted at MNIT Jaipur. What exactly is the necessity was rather full-scale testing? See, Bureau of Indian Standard currently doesn't have any guidelines, specific guidelines or standards related to testing and acceptance of any new construction technology or method. Now, it's very risky to implement any system or any new construction building system for in a real size or life size structure, because the occupancy in any building structure of a meterized story, let's say 10-story building having 10 flats or 8 flats per floor, so we are talking of 80 number of dwelling units, and each dwelling unit would accommodate somewhere around 5 people. So 80 into 5 is 400 people. Even the plane which got crashed at Ahmedabad, the capacity of that plane was 300 people, and 270 people was the occupancy, and everything was all the only one person could save. So the safety is of a very paramount importance as far as residential building or any building is concerned. The occupancy in that building is very large, and without making the presumptions validated, it's not appropriate to use that particular construction system. The modeling, analysis, and design, as far as precast structure is concerned, the analysis and modeling tools are more or less similar what are being used in normal conventional cast in situ structure. As far as design load standards are concerned, those guidelines are available in Indian standard. IS 13920, which is specific about the ductility, particularly the performance during the seismic, that code recommends that precast construction can only be used if they are designed to provide similar level of ductility as that of monolithic RC structure. Now, this is only a one line statement which allows use of precast construction system in buildings, but only when it is established that the precast construction is providing similar level of ductility as that of monolithic RC structure. So BI standard currently mandates that any new building construction system has to have a performance assessment and performance test. With this background, Central PWD, CPWD has also issued two office memorandums which stipulates the requirements, the procedure for full-scale testing and its acceptance criteria. BMTPC has done a lot of work, particularly in shortlisting the technology, identifying the technology on the scale of various acceptability limits. And this Office Memorandum of CPWD supports the work carried out by BMTPC. We all know that precast construction system are being used in India since long. It's almost 6 decades. We also know that there have been one major incidents wherein the precast system has failed miserably. This particular incident has happened when the Gujarat Bhuj earthquake happened. That was in the year 2001. The primary school buildings, almost 5,000 school buildings were constructed using precast wall panels and slab and column and beams as well. All these structures were ground story structure, and almost 75% of these primary school buildings were damaged, and almost 25% were collapsed during Bhuj earthquake. So also recently, one 3D volumetric prefab structure was tested in one of the leading lab in India, and that hasn't met the acceptance standard. So it is very much necessary that the design assumptions are required to be validated, because these building systems will accommodate large occupancy in the building. And that is exactly the necessity of having a test completed. Now, why this test is necessary? It it ensures that the design is performing, the detailing is as per the acceptance, the production methods are in line with what has been considered in the design and analysis as well as detailing, and the installation meets the safety standard. So full scale test doesn't only confirm the acceptability of a particular building construction system, but also the workmanship, the design skill, and the installation methods. And that exactly is the necessity why we must go with a full scale test. Our system, I won't describe too much about what exactly is the 3S PPAP system, which I am going to highlight today. Since introduction of this system in 1970s, lot of performance assessment tests have been conducted at various institute, various laboratories in India as well as overseas. These are those photographs which the testing was done. It was either the componentalized level, sub-assemblage level, or even a full scale. The first test which we conducted was a representative two-room, or rather one-room structure of 2 story from real size building of S plus 24 story. The actuators were installed at 2 levels. The building was subjected to reverse cyclic load testing, and the cycle was from 0 to 1 millimeter, 1 to 0, 0 to -1, and -1 to 0, such 3 cycles. And then 3 cycles complete one set of cycle, and then the displacement were increased from 1 millimeter up to the capacity of the actuator. And whatever is the load resistance for a given displacement, that was recorded, and the mapping of cracking was carried out, and the ductility level, the drift level were assessed. Thereafter, this is also another test which was conducted on a real size S plus 22 story building and 32-story building. S plus 22, rather 23-story building, was comprising of column beam slab structure with the infill masonry wall panels, and 33-story building was comprising of precast RC wall panels with slab. So two structural system. One is column beam frame system, and another is a load bearing wall panel and slab system were subjected to test. The first two series of tests were conducted in the year 2022 and 2023, and then in 2024, 3 tests were conducted on load bearing wall panel structure. I'll just show you what exactly was the test video captured during the first test.
ground acceleration of 0.24 g and constructed using 3S prefab system was tested for pseudostatic reverse cyclic loading in orthogonal directions. Experiments completed by loading the structure for 20 hours. The test house certified the ability of industrialized 3S prefab system to transfer earthquake loads of much higher magnitude than the designed seismic forces through its distinctive connections, and hence the acceptable performance of the system is patently evident in seismic zone 4 for any number of stories. Shirke construction technology.
So you must have seen the structure was literally deflecting. The displacement under this test was to the tune of 120 millimeter. 120 millimeter structure was displaced. It was a reinforced cement concrete column beam frame system, and no major visible cracks were seen. The capacity of actuator got exhausted. It was 100 metric ton actuator which was installed at the topmost story, and the performance assessment was carried out of a middle story. Why middle story? The middle story is the representative floor of that 23-story building. Since the bottom story is anchored fully with the strong floor and top story is attached with the actuator, the boundary conditions are not as similar that of a real size structure, but the middle story has the similar boundary condition of a real size structure, and that exactly is the necessity why we must go with a 3-level structure whenever we have to assess the real size performance of the structural system. After completing this first test on that column beam frame, we actually conducted 2 tests. One was in the steep direction, and then after completing the test in the steep direction, the actuator was installed on the flexible direction, and again the same structure without any retrofitting was subjected to push-pull reverse cyclic loading. So the same structure was subjected to both direction test load, and the performance assessment was carried out. You must have seen that the actuator, the resistance from the structure was to the tune of 5.65 times the design basis earthquake load. So that much was the resistance recorded under 120 millimeter displacement. After completing the column beam slab assessment, we subjected this load-bearing wall panel and slab panel structure again for reverse cyclic load test. Since the stiffness of this wall panel structure is pretty high, instead of one actuator, this structure was loaded with 2 actuators. Both are placed at the topmost story. I'll just show you how the structure performed during this load test. So the performance was hard, the displacement was hardly anything, under 200 metric ton actuator load at the topmost story. So it was decided that we'll cut this structure in 2 parts and the stiffness will get reduced by 50%. After cutting the structure, again it was subjected to load, the same set of actuator. So on the left side, you see that the same structure was cut vertically, and 2-room structure was again subjected to load. On the left side, you will see the structure is subjected to load. This time, the displacement was a little bit higher than the earlier structure. But no major crack were seen in the wall panel as well as wall to wall joints or even slab to wall joints. So after completing this test, it was decided that the leftover part, which is only one wall with a part of a slab, was again subjected to loading on other direction. On the right side video, you will see that leftover part, which is basically one single wall with a part of slab diaphragm connection, was subjected to load in the in plane direction. Now this time it was not only the displacement, but the torsion was also exhibited to that part of the structure. Again, no major cracking or unacceptable cracking were noticed. On the right side, you would be rather the rotation or the torsion is visible. So this is how both the tests were completed, and it was revealed that the resistance of the structure was 5.65 times to 7.8 times than the design lateral load capacity. And when one singular part was subjected to load, it was 6.07 times to 11.6 times the design capacity. So that exactly is the necessity of conducting the test. I'll just give one example. What happens whenever we study in the engineering, we attend the classes, then unless we face the examination, no one is declared to be qualified as an architect or as an engineer or as a doctor. So examination or testing is very much essential to qualify that the structure or the product performs to the accepted standard and accepted norms. Now, lot many facilities, load test facilities are available in India. It's not that only MNIT Jaipur has the facility, but CSIR CBRI lab at Roorkee also has the similar facility. Vallabhgarh also has the similar facility. IIT Kanpur also has the facility. ACRC Chennai also has the facility. There are lot many facilities available now in India for conducting full-scale tests. Apart from the structural assessment, the other load tests are also carried out on the projects during construction, and those are typical floor load tests. This is of course a vertical load test, then water tightness test that is essentially required to be conducted on every structure. These are few photographs of the buildings which we have completed using either column beam frame structure or load bearing wall slab structure. You would see that the delivery is to the tune of 9 flats a day if wall slab construction system is deployed, and if column beam frame system is deployed, the completion could be as much as 15 flats a day. These are different buildings which were completed using the same system. On the left side, you will see that this is a 29-story building of a Y shape. Then at the bottom, it's a 27-story building at Taloja, Navi Mumbai. On the right-hand side, it's a 39-story building at Goregaon, Mumbai. All these buildings are precast prefab building, RC buildings. No pre-stressing, nothing. So 80-meter high, 100-meter high, as well as 120-meter high buildings were completed using the same system. And that exactly gives us confidence after completing the test that yes, the building can be constructed using precast system to any number of stories at up to any number of height. So height or elevation or a feature is not at all the restriction for precast construction. Now I'll share with you the design aspect about precast construction. Here I will cover our live case studies of two projects. One is that 29-story building and other is 39-story building. To complete the projects on this scale, the organization has to have a lot of expertise and experience as well as other resources, particularly in terms of equipment and machinery. That is only the success of precast construction. These two projects which I am going to share with you as a case study is one is at Pahadi Goregaon, which is a 39-story building, and the other one is at Jogeshwari Oshivara, which is a 29-story building. Both the projects have been completed, and both the projects were for Maharashtra Housing Area Development Authority. One is the first project is of is having EWS, LIG, MIG, and HIG type housing units. Particularly in this 39-story building, there were only MIG and HIG category type houses. And as far as the 29-story building is concerned, that project is basically a High Court Judges Quarters project. It's a super high category housing of almost about 1700 square feet carpet area. The first project of 39-story building, the sites were scattered at two locations and it is right in the slum area. So the accessibility issues, the casting, the manufacturing unit were not within the project site, but the components were manufactured at almost 30 kilometers away from this project. And then the components were transported and the construction happened. There were total 10 dwelling units per floor, 3 of high income group and 7 of middle income group. In one building, there were total 332 dwelling units. Now the occupancy of this building, 332 into 5, is almost 1,600 people in one building. So the life safety importance compelled us that we must use the system only after completing the test and performance assessment. That was the commitment, a professional commitment from any organization who does the construction work consistently and continuously. So this was the configuration floor plan of that project. Each unit, MIG unit carpet area was 72 square meter, HIG unit was 89 square meter. This is typically a load bearing construction system, wherein the shear walls were placed and planned in such a manner that we will have the placement of shear wall in both the direction X, Y as well as the core. This is that tower after completion. And the judges quarters, that is 29-story building. It's 110 meter high. Total tenements, the flats were 91. So 91 into 5 is almost 450 people. Again, this building system was wall panels and slab. Typical unit layout. Then this carpet area was revised to 99.4 square meter usable carpet area. It was increased after the review happened with High Court judges. This is the building after completion, how it looks like. See, when we started the designing and planning of this particular building, we also conducted an overview where exactly the reinforced cement concrete precast construction system have been deployed on high-rise building. We found that there were only 5 projects all over the world wherein real precast RC construction was introduced, and there was no other load transfer system, either composite construction or any other cast in situ construction. So purely precast reinforced concrete buildings constructed above 100-meter were identified, and what exactly was the system that was studied. So this is one building of 120-meter high, 33 floors above ground, having total coverage area of 37,000 square meter. The construction started in 2007 and completed in 2010. So this is the first building, precast building, which was completed. Of course, not in India, but outside. Then the other building is in Netherlands, which is a 43-story high building. Again, full precast construction system. So the construction site was hardly 30-meter by 35-meter. So constraint of space. And this structure was also completed in 2007 with an average of 2 floors per week. That was the speed which was achieved. Then this is another, the same building rather, in Netherlands, wherein the precast wall panel system was deployed, and the jointing was not a cast in situ emulative joints, but some other method of jointing. The same building. Then another building, which is a 36-story high building, it's 110-meter high. This was completed in 2004. Again, the system is load-bearing wall panels, precast RC wall panels, and slabs. This is in Singapore. Most of us might be aware, it's a very large project, 135-meter high towers, and the floor plate area is 46,000 square meter. Again, this building is completed in precast RC construction only, load-bearing wall panels and slab. So first the study was conducted, then what exactly was the system deployed over there, and what was the seismic force demand in that particular area was also studied, and then the jointing system was studied, and then we arrived at a peculiar jointing system to be made applicable for our local conditions for the buildings which we constructed. So we came up with a system that instead of having a complete dry jointed system, we use hollow core wall panels. These are not pre-stressed wall panels, but these are reinforced concrete wall panels. The use of hollow core wall panels facilitated us that the reinforcement continuity happens from one element to other element, and the monolithicity can also be achieved. So this was the major change what we implemented than those 5-6 completed buildings, not in India but elsewhere. Of course, the design weighting had been conducted from various renowned institutes. This we had already covered. Then we also conducted a study, comparative study. We built almost 78,000 houses in Delhi. Delhi lies in seismic zone 4. These high-rise building which I am emphasizing, these buildings lies in seismic zone 3, Mumbai. So we compared what exactly is the seismic demand and what is the wind demand. So Delhi has the structure which are low rise structure, 18, 19, 20 story structure, has the seismic design base shear demand of 2006 metric ton, whereas these high rise building constructed at Mumbai had a seismic demand of almost about 1500 to 600 metric ton. So the seismic demand is quite low, but the the wind demand, or rather the wind forces being a high rise structure, was quite high. So of course wind is also governing, and to some extent the seismic forces are also governing. Then the particular precast element what we use for this construction, I already explained the precast core wall, then partial precast beams. The beams are cast up to the soffit of the slab, and the top portion, the thickness of slab as well as screed, is getting cast as a in situ, so that the top reinforcement of beam can be anchored into the cores of a shear walls. Then staircases are also precast, partial precast. The slabs were also partial precast. The component planning was done. The emphasis was basically where exactly the crane would be located, then the accessibility of the trailers to the construction site, because the components were being transported almost 30-35 kilometers away from the site. There were restrictions on the turning radius of the trailer, or then there are a lot of restrictions in terms of transporting such heavyweight components from the city, within the city. So the component planning was done in such a manner that the crane capacity is optimum and the component can be transported long distance, and there will be minimum wastage or breakages of the component, rather almost nil during transportation. So the hollow core walls were manufactured with a peculiar normal shuttering system. The cores were formed using expa mesh, and the reinforcement detailing is done as per the shear wall detailing, wherein the confinement is facilitated through the interconnecting cores of, or rather through the interconnecting loops of the solid shear walls. This is how the shear wall looks like after casting. Then the lower story reinforcement coming from the lower story shear walls gets anchored into the upper story shear wall into the core, and then the concreting happens within the core. So when the walls are installed in the permanent building, there is no hollow cores which left inside the shear walls. All the cores are filled with the concrete. Sorry. See, the elements has typically 2 hours fire rating, severe exposure conditions. These are standard norms as per the Indian standard. All the loading are considered as per the prevailing Indian standards, IS 1893 as well as IS 875. Then the analysis was conducted. And the seismic analysis was completed, and the base shear distribution was also plotted. Particularly for the Y-shaped building, you will see that the base shear distribution is not uniform or particularly parabolic nature, because the mode shape changes in the Y-shaped building. See, the building has almost 1.93 to 2.2 ton per meter square load intensity. This is head load and live load of the building. So the live load percentage is hardly about 19% of the total load. The load combinations are same as that of cast in situ construction. And then the story versus displacement, the drift level are well within 0.4%, what is the upper limit imposed by IS 1893. These slabs are typically half slab, that is lattice girder slab. The minimum thickness is 75 millimeter when the slabs are cast, and then the top screed is laid after erecting the slabs. In Mumbai, the building which is located at Pahadi Goregaon, it has a pile foundation, whereas at the Jogeshwari, the Oshiwara, it has a rock foundation because the rock was available almost at 5-meter depth below the ground. So no need of pile foundation for that particular building. The progressive collapse detailing was done as per the code. See, all our emphasis in the precast construction is that we we typically avoid use of dry joints, and the jointing happens through cast in situ joint. The percentage of cast in situ is almost to the tune of 20 to 25% of total concrete. So minimum 20% in situ jointing is introduced in the building, and that facilitates anchorage of reinforcement and integrity of one element into other element. So this is basically the difference. On the left side, you will see that the reinforcement get anchored from one element into other element. On the right side, you will see the typical wall-to-wall joint, the load-bearing wall-to-wall joint, wherein the continuity happens from lower story to upper story. Two precast wall panels are placed at a distance apart, and the stitching joint is cast in situ concrete, having reinforcement projecting out from one element and another element, and those are integrated with the in situ joint. These are typical details of the hollow core walls and beam and slab connection system. So the beams reinforcement gets anchored inside the core, and then the core gets concreted. So that's the beauty of using hollow core wall panels. On the right side, you will see the construction of wall panels, rather the installation of wall panels, then beams and slabs. This is how the elements were erected. This project is ongoing. The height of building is varying from 90 meter to 109 meter. Floors are 29 story to 35 story. This project, the work is going on this. The same system is being utilized on this project as well. This is the site photograph when the foundation was completed. This project has already been completed using the same system, wall panels and slab. This is for Shirke, City Industrial Area Development Corporation. The height of structure is 80 meter. The number of floors are 27 floors. On the left side, you will see the finished building. On the right side, when the construction is going on. This is that Y-shaped building at Surbi when the construction is going on. This is the snapshot of the production facility wherein the precast element were manufactured. These were manufactured at Taloja factory, and those were transported to Jogeshwari or Pahadi Goregaon, almost 30-35 kilometers away. Then the erection of wall panels is happening at the site. Here you will see that the dowels are projecting out from the lower story. Those gets anchored inside the cores or the ducts created to the of the upper story wall. These ducts are kept intentionally open because we have to ensure that full joint is filled with the concrete or with non-shrink ground. So we typically avoid using sheathing pipes or concealed joint. The joint must be visible and open for anybody to inspect whether the joint is fully filled or not. So on the left side after completion, on the right side when the construction was going on. So this, of course, this was standalone building, so only 20 elements were required to be erected per day. This is the snapshot from the factory. So the reinforcement detailing is pretty similar to what we use in cast in situ construction. The peculiar thing is that how the jointing happens, so how the joint or pockets are left, and after installation, these pockets get filled with the stitching concrete or non-shrink grout, as the case may be. So different types of element, the weight of element was varying from 4 ton to 10 ton. 10 ton was the maximum weight of element which we use on this building. Then the special arrangement for shifting and transporting the element. We tailor-made this trailer, a low bed trailer, because the height of wall is almost 3.15 meter, and there were restrictions in transporting the elements within the city because these the site was accessed through subway. So the height restriction was there. So we have to have a low bed trailer. The installation happening at site. So after the in situ stitching and jointing, you see a very seamless construction happening. This is a wall. On the left side, you will see the wall to wall joint. The reinforcement gets anchored from one element to other element, and the joint is filled with a regular stitching concrete. The shuttering is used at this face. On other face, there is no need of shuttering. This is what we practice because we have to ensure that the joint, every joint is filled fully. The reinforcement must be open for inspection, and then only the joint can be allowed to be filled with the concrete. This is the top view after when the construction was going on. See, on the left side, you will see that lot of slums. This building, this structure is surrounded by a lot of slums, a low-rise building. The access to this site was only 6-meter wide road. That's it. There was hardly any space to store the components. So the moment trailer moves inside the site, the erection happens. Erection was happening at that site. The case studies were about the residential building. This is an ongoing commercial complex. This project is going on. It's not yet completed. It's column, beam, and slab construction. Here the basement, it has a 2-level basement. Even the basement retaining walls were constructed using precast wall panels. The wall panels are again the same hollow core wall panels, wherein the in situ the core filling will be with in situ concrete, and the reinforcement continuity is feasible from raft to the upper story walls. Look at the line level and the quality which can be achieved using precast concrete construction. Then the columns. The grid is 8.5 meter by 8 meter. That's the building being a commercial building. The column spacing is 8.5 meter by 8 meter. So we The shape of column is such that it was a octagonal column, and because we require a bigger size of column, again these columns are manufactured as hollow, and after placement of beams, the central core gets concreted with the in situ concrete along with the screed and the beam top. From the column, you see the reinforcement projecting out that gets anchored into the core of a upper story column. So we get a proper reinforcement continuity from one element to other element. On this precast slab, the screed concrete will be laid after placing the reinforcement. Look at the line level. All these elements are reinforced cement concrete elements, no pre-stressing, nothing. And these are the photographs, or rather the actual photographs of buildings completed in Delhi. So the elevation or feature, nothing prohibits to for precast construction to be used. So anything and everything is possible. That's it.
Thank you, Kajale. There are a few questions. Would you like to?
Yes, please.
So I will read it for you. Okay. There is a question. Please discuss ductility provisions of joints and corresponding detailing. What R value is recommended?
See, after completing the test, our test, the R value, what was achieved is 5.4 for column beam slab structure, and for wall panel and slab structure, the R value what can be safely adopted is 4.8. But of course, IS 1893 stipulates the R values, so we can't adopt the R values more than that. So for our system, we are using the same R values because those R values have been confirmed through the test. Now, there is one more point which was one question which was asked, how the ductility is achieved. Now, what exactly is the ductility? In a very simple term, I define ductility as ability to undergo deformation without collapse. So how do I introduce that ability in precast construction? How do we introduce that ability in cast in situ construction? We basically anchor the reinforcement and we provide the confinement. Now our peculiar system of construction is the hollow cores which gets filled with the concrete after erection. These hollow cores facilitate us to provide the continuity of reinforcement from one element to other element. You must have also observed that to form the hollow cores, we use expa mesh. So I get the confinement through expa mesh as well as through the reinforcement which is placed inside the precast shell, and the reinforcement placed inside the core of that particular element. So that is how the ductility in our system can be achieved. There could be, of course, many other ways to achieve the similar level of ductility, but this is what we practice. I hope I have answered this too.
Yeah. I think you have answered it very nicely. Kindly also discuss the types of connections, whether wet or dry, and how the components were checked for cracking and punching on lifting.
Yeah. Now the first question is about connection wet or dry. I shall open that. The dry type connection The precast construction that way is not very new. All our old temple structures are constructed in precast. The material is not reinforced concrete, but material is stone. So all those connections are dry type connections, wherein major reliance is on the weight, the gravity load of that element and the friction of one element onto the other. So typically those connections are considered as a dry type connection. Dry type connections are not proved very well in high seismic zone area, and that exactly what has happened for the precast construction or the precast school buildings which collapsed during Bhuj earthquake. Those connections were majorly the dry type connections. Wet type connections or emulative connections are typically the connections wherein the two elements can gets joined having a in situ joint. So we must see to it that there is a gap created between, let's say if it is a wall panel element, there is a gap created between two wall panels which gets wherein the reinforcement can be anchored from one element to other element and the in situ stitching joint can happen. Yeah, sorry. So this is that bed jointing and dry jointing. On the bottom side, you will find that there is one precast column, corbel, and the beam. This is typically a dry joint connection. So the reliance is on anchor bars and the friction. In wet jointing system, you have a minimum 20-25% wet concrete which can be used. There is one very good handbook, Mark Pintel handbook, which also emphasize on 20% wet joints to be used with cast in situ construction to facilitate a better way of achieving ductility. It's not that if one uses 20% wet joint, the ductility by default will be achieved, but that is a better way of achieving the ductility. The reinforcement detailing plays a vital role in achieving ductile joints. So that's the difference between wet joint and dry joint. What was another question? I just forgot.
And how do you check for cracking and punching and lifting?
Yeah. See, we have a set of system. Basically, cracking is visual observations. As far as slab elements are concerned, the moment the slab elements are erected and the water is sprinkled onto the precast slab, if at all there are cracks, those cracks get visible through the wet lines, the water lines running along the cracks. That's only visually the cracks can be inspected. There is no other way which ensures the rather which by which the cracks can be checked.
Okay. Okay. The next is, I think, jointing. You have already. Please discuss about installation and jointing details.
I already talk about installation and jointing details. This is basically the jointing details. The see hollow core walls has in the precast part there is a reinforcement. Then the outer leaf as well as inner leaf gets connected through the interconnecting concreting leaf. And in the hollow core, again the reinforcement is placed at the joint level. And then this hollow cores get concreted with the in situ concrete. The beam elements has from the bottom reinforcement gets projected out from the beam, precast beam. The links are projecting out above the beam, and the top reinforcement is tied at the top level through these rings. So this is how the jointing happens.
Okay. Next question. Yeah. Please go ahead. Go ahead.
Yeah, and there was one more question: how the erection happens, the installation basically.
Yes.
So the installation is pretty similar. You have to have a lifting girder. Then first the wall elements are erected. Till these inclined push-pull props are attached to the slab and to the wall element, the, the element has to be held with the crane. So till that time, the crane gets engaged. Once on the bottom left side, you will see that these inclined yellow members, those are push-pull props. These props can pull the element as well as can push the element. First, those props are fixed on the slab and then attached to the precast vertical element, and then the alignment and plumb is done with the help of pushing or pulling action.
Okay.
Yeah.
Okay. Next is next question is
Sir, Matt.
1 minute. Next question is what about MEP services? MEP services in precast and future में change नहीं कर सकते हैं.
See, all MEP services are integrated at the time of manufacturing of wall elements. Okay, means may it be electrical conceal wire or plumbing lines. Typically, what we recommend that in case of mass housing, this बाद में installation होने के बाद में काफी लोगों को कुछ ना कुछ changes करने का दिल चाहता है या करते हैं वो. If the function the usages changes, what we recommend is that the plumbing lines, vertical lines, are running on surface inside the ducts of the toilet shafts. So those can be replaced at any time because those are visible not from the inside of the flat but outside within the duct. In addition to that, wherever we find that there is a possibility of amalgamation of two adjoining flats or amalgamation of two adjoining toilets to convert into a bigger toilet, there we intentionally introduce one partition wall which is constructed with normal AC block so that afterwards one can change those particular thing. Apart from this, we issue a operation and maintenance manual to every flat owner or rather to the society wherein the layout of the concealed services lines, may it be electrical or may it be plumbing, is indicated. The lines which are concealed on the walls, typically we prepare a dado tile pattern in such a manner that there will be a different colored tile so that it can be easily identified that here the line is concealed.
Okay.
Likely changes in future.
Okay. The next question
Still, can we replace steel by FRP?
No, FRP still is not recommended for structural use application. In the first place, FRP is very good in tension, but not good in shear or compression.
Okay, let me complete these questions, then we will ask
Yeah,
participants to ask. Okay, please don't ask in between. Another question is repeated floors like housing is possible. What about other types of buildings?
See, anything is possible in precast.
Yes.
Everything is possible.
Okay.
The system basically here, you will see on the screen, you will see that how the manufacturing happens. There is a pallet. It's a 3.5 meter by 12 meter long pallet wherein the elements are cast. Now, any shape of element or any size of element can be cast simply by changing the location of side shutter. So it's possible that non-repetitive flats can also be constructed. The only thing will be that there could be some cost addition if the repetitions are not there.
Okay.
Yeah.
Next is how China is doing a skyscraper hotel or housing just in 10 days. How they are different from us.
See,
Yeah.
10 days is just impossible. What China is doing, may it be 3D volumetric construction. Our experience is that on a project, now let's say it was a lighthouse Chennai project.
Yes.
The working days were 250, 1 year. 250 were the working days, and the total number of dwelling units were 1152. Now, 1152 dwelling units were completed in all respects and were ready to occupy in just 250 days. So, per day, we completed 4.6 dwelling unit. That was the speed which was achieved at Chennai. On Sidco project at Taloja, we delivered 15 dwelling units per day. Project start to project completion and total number of dwelling units. So 15 dwelling units. So the speed of this construction is 4 dwelling units to 15 dwelling units per day. Everything depends on the number of resources which can be deployed on a project. There, if the project is located in a very congested area, there will be a lot of limitations in deploying more number of resources. So naturally, speed will be less, but the quality will not be compromised if it is switched over to precast construction.
Okay. Next is what about wall conduiting for running services?
Though these services are integrated when the components are manufactured itself.
Okay. Uh, Next is how waterproofing is done at joints, particularly at basement retaining walls.
See, our basement retaining wall was used, or rather we use the hollow core elements. The two hollow core elements has a half core, particularly at the joint.
Okay.
See, on the left side, you can see these cores are full, but on the bottommost part, left side bottommost part, there is one open core. So here is wall to wall joint. So that vertical joint gets concreted with the in situ concrete, and then a normal waterproofing treatment is applied onto the external surface of the joint. Even we had constructed water tanks using the same system.
Okay. Next is how the staircase is assembling for the columns.
Staircase assembling from the column. This is on the right side. There is a staircase which is being erected on the right side photo.
Correct.
So the staircase is resting onto the beam. This beam will rest either on wall or on column.
Okay.
So staircase is resting on the beam. The beam frames into the column or could be onto the wall. And the angle of inclination of the staircase, the beam will also have the same angle at the bearing point.
Okay. Next is please explain how displacement-based design is followed in precast concrete structures.
Displacement based design, basically our Indian standards, we design the buildings using our Indian standards. In our Indian standards, our designs are not displacement based, but we check the displacement for the limits stipulated in the standards. So our design method is basically the force demand or load based design, wherein the displacements or deflections or drifts are restricted. Accordingly, the stiffness of element, the sizing of element is decided. Displacement based design is possible, but that's not necessary or need not be done It can be even the force-based design. With displacement-based design, we can still further optimize the construction, or rather the quantities of concrete and reinforcement.
Okay. Okay. The next is, does the structure should have alternate load paths? So if one element fails, others can carry the load.
Yes, it is always recommended. Alternate load paths are necessary. But now in case of wall panels and slab, if one wall panel gets displayed or rather dislocated, then the slab will have will have a double span. That is, practically it won't be possible. Of course, the slab element won't collapse. That is how the detailing is done. In our code, we have the progressive collapse requirement, and based the provisions of progressive collapse are incorporated in every design. May it be precast, may it be cast in situ.
Okay. Sir, can you kindly name the types of precast elements that would be used in high-rise precast buildings other than hollow core walls?
There could be solid walls and beam elements, solid wall, beam elements, slab elements, staircase, lintel chhajjas. See, these hollow core or solid walls, it all depends on how the continuity and necessity of continuity is required. We can have, instead of having a full hollow core, we can have two hollow cores at the end, boundary locations, and middle part could be a solid wall.
Can you also mention the grade of each of these precast elements?
We use minimum M40 grade of concrete. Why M40? Because when the precast elements are cast on the mold, at the time of lifting the elements, we require minimum 12 MPa to 16 MPa strength, depending on the size of element and shape of element. Now, to get this 10 to 16 MPa strength in 12 to 14 hours, naturally 28 days strength is 40 minimum. So these precast elements, we use typically minimum M40 grade concrete.
Okay. Can we make precast for industrial structures which are having 3-meter depth beam, 9-meter diameter bunkers having high vibrations?
Everything is possible. See, precast is what basically? It's reinforced cement concrete, the same construction material. What is important is, do we have that lifting and handling capacities? If it is possible, whether those are cost effective or not, if it is cost effective, it can be done.
Last few questions. How does seismic load affect precast structures differently than monolithic structures?
The major difference is the jointing of precast construction, the joint of one element to other element. Now, in monolithic construction, we can cast the entire 8, 9, 10 meter length of wall in one go. That casting of entire 8, 10, 9 meter wall in precast may not be possible every time. So we have to break the wall maybe in segments 2 meter, 3 meter or 4 meter, another 3 meter, like that. So the wall to wall joints are critical. As far as horizontal joints are concerned, in cast in situ construction, we get a completely in situ stitching over the lower story element. In precast, again, that horizontal joint is critical. So precast versus cast in situ, the major difference is in the jointing method.
Yes. Another question is, did you perform risk analysis?
Yeah, of course. Risk analysis, see, for any organization like us, we started precast construction way back in 1972. And our major business, almost 95% turnover of our organization is into precast construction. So if anything goes wrong, then it will be a existence issue. So risk analysis is always carried out.
बड़ा ही बोरिंग और बकवास था।
Okay. Okay. There is one question on embodied energy. What about embodied energy of these panels? Is there any document for reference for the same?
That study was conducted, embodied energy. See, the construction material is same.
Same, yes.
So whatever embodied energy is there for cast institute construction, the same embodied energy will be here in precast construction. There won't be much of a difference.
Okay, and let's come to last question. What about features? What are the features the precast concrete should have for water tanks? Which precast elements are used for such water tanks, and what is their grade?
For water tanks, we typically use these hollow core wall elements and half slab, because the main, rather the in water tanks we require a leak proof construction. Now to get that leak proof construction, each and every joint we emphasize that it is concrete, it has a in situ stitching concrete, cast in situ concrete. So with this hollow core method, we are able to achieve that water tightness. Of course, the waterproofing methods are more or less same, rather exactly the same what we use for cast in situ construction.
Okay. For high-rise buildings, among the different precast elements mentioned, which of them having pre-stressing?
None. Not a single element was pre-stressed in the case studies which I shared with you.
Okay. Next is it feasible to use precast structures in construction of chemical laboratory building? Yes. Of course, yes.
Of course.
Yeah. So I think that was the last question, Kajale. I think you have answered everything very explicitly and in detail. Thank you very much. And I'm pretty sure that participants got benefited by such a wonderful and enlightening lecture by Kajale. On behalf of everyone present here, let me thank Mr. Kajale for such a great lecture. And as you can see, they have evolved this technology over the year, and there is no fear about using precast when you do this kind of cast in situ jointing and other things. So thank you very much to be part of this webinar series. All of you will get the recording of today's presentation on our YouTube channel. And with this, in case you have any other doubt, please do write to us on our email ID, and we will forward those questions to Mr. Kajale and try to get the answers for you. In case you want to use this technology for your future projects or future endeavors, or if you won't have any other doubt, we can also connect you with Mr. Kajale, and you can take advice, you can hire them, whatever way you like. So thank you very much, everyone. And before we depart, if all of you can open your camera, we will take a group photograph. Kajale ji?
I'm trying to open my camera. One second.
How is your mother now? How is your mother?
Yeah, she's improving. Her age is the main criteria.
So I pray to God for
yesterday
her.
only. Yeah, yesterday only she got discharged. But
so somebody is asking, when is the next webinar? Every month, third Wednesday, we are holding this webinar. Okay.
Oh, yes.
Yes, Kajale.
Yes.
So I'm just taking a photograph now.
Yes, please.
All of you, please open your cameras. Yeah, that's good. Okay. Okay, thank you, everyone. Thank you, Kajale ji.
Thank you, Shailesh ji, for wonderful seminar, and you're doing extremely. The BMTPC, I have seen a lot of such efforts are being made at your organization, specifically by you. And due to this only, there are as many as 54 technologies which have been shortlisted, and many, I'm pretty sure that many will be in use in future. Thank you.
Thank you. Thank you, one and all. Thank you. See you again.
Thank you, sir. Thank you.
Thank you. Thank you. Thank you.
Thank you, sir.